Hello and welcome to the second part of the high school chemistry. So the first thing that we'll talk about is diatomic elements. So these are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So these elements, they require to be bonded with one another. So like hydrogen needs to be bonded with another hydrogen. So you have H2. So an easy way to remember this is by going to 7 on the periodic table. So right here, the nitrogen has a 7, the atomic number, and you make a 7. So you go from nitrogen, oxygen, fluorine, and then chlorine, bromine, iodine. So the 7-7-7 rule. So you go to 7, make a 7, and then you also have to include hydrogen because that is one of them. And there should be a total of 7 diatomic elements, which you have right here. So today, the main thing that we'll learn about is protons, electrons, and neutrons. So a proton has a 1+ charge, and it is located in the nucleus. The mass of a proton is about 1 AMU, and an AMU is the unit used to measure the mass of atoms. So a neutron has a charge of 0, and it's also located in the nucleus, and it has about a mass of 1 AMU. An electron has a charge of 1-, and it is not located in the nucleus. It actually orbits the nucleus, and the mass of an electron is about 0 AMU. So here on this table, I've included 4 elements from the periodic table. And this is how you can tell the number of protons, neutrons, and electrons. So for the first example, we can look at aluminum. So if you look at the periodic table, aluminum is number 13. It's the very top green, dark green, number 13, aluminum, Al. And as you can see, the atomic number is 13 from up here. So if you go back to the table, you have the atomic number of 13, and the mass number is the mass, which is like average mass is the same thing. So like right here, it shows mercury as 200.59. For aluminum, it's might be a little hard to read, but it says 26.98, which is around 27. So that's why we would write the mass number of 27. Now, to find the number of protons, it would be the atomic number. And then the neutrons, you would do the mass number minus the protons. So 27 minus 13, which is 14 neutrons. And in a neutral element, so these are all neutral. We'll go to not non-neutral elements in a little bit, but these are all neutral. So that means that the number of electrons would be equal to the number of protons. So if we would go to the next example, that is Ti, which is right here where my cursor is. Number 81 is the atomic number, and the mass is 204. No, I was looking at the wrong one. Sorry. Ti, it's right here, number 22. Atomic radius of 48. The atomic number is 22, and the mass number is 48. So this one. So if you look at here, atomic number 22, which is, you can see it right up here, 22. And then the Ti under it is the atomic weight, also called the average mass. It's right here as 47.68, which would be 48. And in this, the number of protons would be equal to the atomic number, so 22. And then mass number minus protons, so 48 minus 22 is 26. And this is also neutral, so you do protons equal to electrons. Magnesium and oxygen, we do the same way. Atomic number for magnesium, which is number 12 right here in the second row, which Mg12 is the atomic number with the weight of 24.31. So we would write 12 for the atomic number and 24 for the mass number. Atomic number equal to protons, and then mass number 24 minus protons, which is 12, you would get 12. Protons is equal to the number of neutrons. Protons are equal to the number of electrons, which is 12 in this case. Oxygen is the last one that will go for neutral. It's number 8 right here. And the atomic mass, or the average mass, is 16. So over here, we write 8 for the atomic number, 16 for the mass number. And the atomic number is equal to the number of protons. And then the mass number minus protons, so 16 minus 8 is 8 neutrons. And the protons is equal to the electrons. So that is for the neutral elements. Now we go to ions, and an ion is a charged atom. An anion is a negative charge, which means that there's more electrons than protons. And an anion is formed when atoms gain electrons. A cation is a positive charged element. It has more protons than electrons, and it is formed when atoms lose electrons. So this is a similar table, different elements though. So we can go over this. The first one is right here, phosphorus, number 15, atomic radius of 30.97, which is around 31. So if you look over here, 15 and 31, we do not change these two. These two stay the same for this element, 1531. And again, the atomic number is equal to the number of protons. And then the mass number minus protons gives you neutrons. So 31 minus 15 is 16. So this much, from the atomic number, mass number, protons, and neutrons are the same as we did for the earlier examples for the neutral elements. But the electrons change. So here you have a charge of 3 minus. And this might be confusing at first, but even though it says 3 minus, you'll actually be adding to the proton number by 3. So 15 plus 3 is 18. And this is because, as we can see here, in an anion, so this is a negative charge. So this is a phosphorus anion. It should have more electrons than protons. It is formed when atoms gain electrons. So this is gaining electrons. You have more electrons. And yeah, so you have more electrons than protons. So that's how you know this is an anion. Next example is Sr2 plus, and that 2 should be like this 3 minus. It's a typo, so sorry about that. But Sr is right here, strontium, number 38, atomic mass of 87.62. So you would have 88, atomic number was 38. So atomic number equals number of protons, 38, 38. 88 minus 38 is 50, which is mass number minus protons equals neutrons. Now, this has a 2 plus charge, and you have 38 protons. So in this case, you would subtract from the proton number. So 38 minus 2 is 36. This is because a cation has more protons than electrons. So in here, you have 38 protons, 36 electrons. And it is also formed when atoms lose electrons. So this one is losing electrons because it is lower than the number of protons. So now the next example was Te2 minus. So that's right here, number 52, with an atomic mass of 127.60. So 52 and then 127.60 is about 128. So now you would do atomic number equals protons, mass number minus protons. So 128 minus 52 is 76. Now this is a 2 minus charge. So you would add 2 to the number of protons and you would get 54 electrons. The last one is potassium, K plus, which is right here. It has a 19 is the atomic number and 39.10 is the average mass. So you would put 19 for the atomic number and 39 for the mass number. Atomic number equals protons, so 19 for each. Mass number minus protons gives you neutrons, so 39 minus 19 is 20. And then since this is a plus charge, you would do 19 minus 1, because if there's no number in front of the plus or minus, it would be 1. So if it was K minus, then it would be basically K1 minus. So in this case, it's K1 plus. So now you would do 19 minus 1, which would give you 18 electrons. So some of the key points from this is that the atomic number and mass number doesn't change. So as you can see, the atomic number 15 and the mass number for phosphorus 31, it does not change from what you would see in the periodic table. Phosphorus 15, 31. So if you look at the first example right here, if this was aluminum 2 plus, the atomic number, mass number, protons, and neutrons would still be the same. All of this would be the same. And then the electrons would change. So if you had aluminum 2 minus, you would add 2 protons. So it'd be 15 electrons. So the only thing that changes is the electron number. So this should say the atomic number, mass number, protons, and neutrons do not change for this, only the electrons. And in a neutral atom, so these are all neutral. As you can see, in a neutral atom, the protons are equal to the number of electrons. But if you look at these ions, whether it be the anion or the cation, the protons are not the same as the number of electrons. So that is one way you can tell if you have an ion or neutral element. And that is it for this chemistry part 2. Part 3 will be out soon. Thank you.